My name is Muhammad. We are from group number 7. We like to present the design project using finite element method magnetic, or we call it FEMM. So here is all my group member name. So for the task 1, we need to analyze electric field for the electrostatic. So we need to create or design two kind of shape. The shape number 1 is the original one that have given to us in the task. We need to create a sphere-to-sphere shape with a 25 cm radius. For the open-ended design, we decide to create here M outline here, 2 sphere. So we call it M2 sphere shape for the shape number 2. For the task, for the result of analysis electric field between the two, for shape number 1, you can see the gap distance here from 1 cm until 70.5 keep increasing. Image for both simulation and calculation keep decreasing, also with the percentage error, also with the field utilization factor keep decreasing. For table number 2, for the shape M2 sphere, the distance also same with the shape number 1. Image for both simulation and calculation also keep decreasing. The difference here is the percentage error. You can see it keep increasing until it come to 70.5. It's kind of drop a little bit here. It kind of decreasing. So field utilization factor also keep decreasing, same with the shape number 1. So here the graph for maximum electric field and gap distance for shape number 1 and number 2. So from these two graph, I can conclude that image is decreasing when the gap distance are increasing. So from the graph sphere to sphere for shape number 1, here the red one is image simulation and the gray one is image calculation. It's kindly close to each other. But for the shape number 2, these are not very close here. For the image, for the electric field simulation and electric field calculation, it's not very close until here.
Assalamualaikum. My name is Muhammad Abdul Hassan bin Muhammadiyah. My matrix number DE170022. So I will present about field utilization factor for all gap distance. From the left, it shows the gap distance from 1.0 cm to 17.5 cm. It also shows E average, E max simulation, and also field utilization. E average, E max simulation, and field utilization is decreased based on the gap distance. The higher the gap distance, the lower the voltage it get, and also the field utilization. For the left, shape 2, it also same gap distance from 1.0 cm to 17.5 cm. It also show the lower voltage got based from the gap distance. The higher the gap distance, and also the lower the voltage. So we show the graph of field utilization factor versus gap distance. The field utilization factor at 17.5 cm of sphere shape is 0.803, and M to sphere is 0.696. So you can conclude that when the field utilization factor increase, produce more uniformly electric field, and the effect from the system can be easily break down, but the maximum electric field very strong. When the field utilization factor decrease, produce less uniform electric field and can prevent the system from breakdown, but the maximum electric field not strong. So we can see at the field utilization factor at 17.5 ampere shape is 0.803. At 0.803 is more better compared to M2 sphere 0.969. Thank you.
Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. My name is Muhammad Alif Bazli bin Bukhari. So I will go through about the task 2, which is about the magnetic problem. So there are two different types, different shapes, as you can see in my slide. For the original shape, we call it as CI core. And our new design, randomly we call it as DI core. So the darker color one showing that this is the higher flux density. But compared for two shapes, we can see the CI core is higher compared to the DI core, which is 2.50 for the CI core, and the DI core 2.3529. The next, I will go to the analysis of force between the gap CI and the DI. So you can see the CI core shows higher value, that is getting more force to attract the I core compared to the DI core, as you can see the result as in my slide. Negative 132.3776, and X component is for the DI core negative 1.66244 Newton. The next is comparison between two graphs, the graph of field intensity versus gap length. So you can see the highest field intensity for the CI core, which is 1.583 mega amp per meter, and the DI core 0.409 kilo amp per meter. So as the result shows, the field intensity of CI core is higher than the DI core. That's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Bainuddin. So today I will continue the presentation for the task 2, which is magnetic problem. So my part is the last part, which is the current density. Before that, I will explain of the figure. This is for the figure CI core, and this figure for the DI core. Around of the coil, we can see the leakage flux, and between of the core, we can see the gap length, and the outward of the between of the core, we can see the fringing effect. And between the fringing effect, we can see the mutual flux flow to the C to the I core. So it's same for the DI core. And the difference between the CI core is the gap length. The gap length of the DI core is bigger than the CI core. So you can see the when the bigger of gap length, we can see the bigger of the fringing effect, and also the mutual flux through the I core is less. So I proceed to the current density. The current density of the CI core is 41.667 ampere, and the DI core is 31.25 ampere. We can conclude that the CI core is a higher current density compared to the DI core. So I can conclude the whole of the task 2, which is CI core is the best performance because it has a high field intensity that produced from the core, and smaller gap length because the mutual flux will flow to the I core from another core. Next, is we produce high current density in magnetic circuit. So that's all from me. Thank you.